In this spreadsheet, we have some fake experimental data. Hypothetically, we had some researchers who wanted to test the effect of cocaine on participants' heart rates. So we have different patients here with the patient identifier 1 through 10, pretty small sample size because you don't want to give a whole lot of people cocaine. So before they gave people the drugs, they measured their heart rate. So we can see we have values from about 56 to a high of about 80. Then they administered the cocaine and waited a couple minutes, 5 minutes, and then at time 2 they measured all these people's heart rates again. So we can glance at the data and we can see, okay, there was a change from time 1 to time 2. And you know what, this change column is not useful. It doesn't contain any data used in this analysis. I'm just going to delete it. Let's simplify this just a little bit. So time 1 is before cocaine, time 2 is after cocaine. So let's conduct a t-test because we want to see, was there a change? Is there a statistically significant change? Or were the heart rate changes all due just to random chance? A lot of statistics, when you're trying to do your best to support causality, does A cause B, you're trying to determine was this due to chance or not. So we'll do a t-test. So a t-test, this is the student t-test. This was invented by someone who went by the pen name Student, worked at a Guinness brewery back in the day, and it was trying to control the process for making beer, so invented a test that's still commonly used today over 100 years later. So t.test is the function that we're going to be using. Then we've got these arrays. Arrays, it's just a cell range. So we're going to use time 1 and time 2. And now hit comma, those are 2 arrays. Tails, one-tailed distribution or a two-tailed distribution. A one-tailed distribution is going to be used when we have an a priori hypothesis. That means we believe that the effect is going to go in one direction. So we could say theoretically, we could use either here depending on what we thought beforehand. So if I said to myself, I think cocaine is going to increase people's heart rates, I would use a one-tailed distribution. If I said, you know what, I think cocaine is going to change people's heart rates, but it could go up or down, I'm not quite sure, I would use a two-tailed distribution. So let's use a one-tailed distribution. And now, is this paired two-sample unequal variance or two-sample equal variance? Those are 3 options. Well, here we have 2 measurements for each patient. So that we have a pair of measurements. That means the first row in these arrays is the same person. So this is going to be a paired t-test, which is typically a more powerful type of test that you can run. So I'm going to choose 1, and we get our answer, our t-test. Highly significant. So significant, it's hard to represent it here. We've got a lot of zeros before the decimal point, and okay, so very significant. That means I would conclude as a scientist that cocaine does in fact, the data supports the notion that cocaine increases people's heart rates based off this data. So we can also calculate the correlation equals correl, similar type of function. Let's try to, and we have a very high correlation. The correlation is 0.59. So a perfect correlation would be 1 or -1. So 0.59, if you were the first person to discover this, you would be excited. You'd be jumping for joy and you could publish this in a scientific journal. So the t-test basically tells us, is the difference significant? The correlation tells us, how strong is that relationship? If you have a very strong relationship, you don't need a lot of samples in order to prove or support. It's hard to say. You rarely want to say prove when discussing science and statistics. If the effect is strong, this is a pretty strong effect, you don't need a large sample size to determine that the results were not due to chance. But now let's go ahead. We can use the analysis add-in to do some more statistics. I'm going to go to File, Options, Add-ins. I want to add the analysis two-pack tool, not two-pack, two-pack's record. Manage the Excel add-ins. So I'm going to click Go. I want the analysis tool pack. So make sure you've got that analysis tool pack checked. So once I've got that enabled, I can come to data now, and I'm going to have some extra stuff. Oops, sorry, click data. I'm going to click data analysis. And there's a lot of analysis that you can do, tons of statistics you can do in Excel. And we're going to do the t-test paired two sample for means. So the means is basically the average. We're going to pair the average across groups. It's paired because each person is measured twice, so I'm comparing these people against themselves. So the variable 1 range, I'm going to select time 1, variable 2 range. Now hypothesize mean difference. So this is basically the one-tailed test or two-tailed test. I'm going to leave it blank. Alpha, that's my cutoff for statistical significance. Typically 0.05 is used in a lot of social psychology. And we'll put this in a new worksheet. Just click OK. And it's going to run it for us. So let's take a look. And it looks consistent with what we had before, with a little bit more data. So we can see the formatting is not awesome. So we can see before cocaine, goodness gracious, after cocaine. So we can see the average heart rate went up quite a bit. We can see there's quite a bit of variance, less variance before cocaine than after. So cocaine seems to affect people differently. 10 observations in each group. The correlation is pretty strong, 0.59. Too many decimal places there. The t-statistic is what it is. So we can look at the one-tail significance versus the two-tail. Both of these are very significant. Essentially, your two-tail is going to be twice as big as your one-tail. But look at Wikipedia for the t-distribution if you want to see why that is. But this is a good way for Excel to generate some of our statistical analysis for us using the data analysis toolpack. But you got to add it in. So these statistical methods are used quite a bit. They're used in marketing to analyze consumer data, to analyze surveys. Using the statistical analysis, it provides a little bit of meat behind your recommendations, because you can say, look, there are actual patterns in the data. I'm not just showing you a pretty graph and there's no statistics to back it up. Here's hard numbers, hard analysis showing that there's a clear relationship between these variables.